Okay, so last class. Okay, we have completed with the literals, and now we're going to start with operators. Any question from previous classes? If you guys have, you can ask. Otherwise, we'll continue.
No, sir.
Okay, so operators are some symbols like this, right? Plus operation, minus operation, and division, assignment, and operator, or operation, like this. These are the operators. Okay, operators are some symbols to perform some operation in any programming language. But when we perform these operations, we need two things. Actually, we need to remember three things we need to take care. Like, say the operator we am using plus symbol. This is the operator I'm going to use. And by using this operator, I want to perform the operation is, I want to do 10 plus 20, right? So operator is plus symbol, and these 20 and 10 is the operand. Okay, these are the operands, and operator is this operand and operator. So we'll wait for 2 minutes. Right, so to perform the operation, this addition, we are using plus symbol, and two operand is required, 20 and 10. After performing the result, we'll get 30. Okay, 30 is the result. So to perform any operation, we are using the operators. So we need the operators. When you're using operators, we need operand as well, operand. and we will get the result. So we need to take care of the operator type, operator which we are using, type of that, operand type, and the result type. Result type which you are using. Okay, remember these things. Operators are used to perform some operation. To perform the operation, we need operand. And we will get the output, the result we will get. We need to take care of the type of operator which you are using. We need to be very clear with this. And for that type of operator, which type of operand we need, and after performing the operation, which type of result we are getting. These three type, also type in the sense the data type in this case I'm talking. Okay, for plus operator, the operand I am using 20 and 10. What is the data type of this? After performing the operation, result I am getting, what is the data type of this? So this also we need to take care. Now, for some operations, for some operator to perform the operation, for example, plus, if I want to perform addition by using plus symbol, we need two operand, 10 and 20. But in some case, I may not need two operand. One operand is also enough to perform the operation. For example, say int a is 1, and I can say a plus plus. So here plus plus is the operator, a is the operand. Only one operand is required. So plus operator needs two operand, plus plus needs only one operand. Or in some case, we need three operand also. For example, you can write something like this. We'll come into that. What is that? True, question mark, some value say 20, and colon 10, something like this. So in this operand is true is the operand, 20 is the operand, 10 is the operand. Operator is question mark and colon. This is one operator, okay? Not two, it is one operator. Like plus plus is one operator. So for some operator, we need two operand. For some operator, we need one operand. For some operator, we need three operand to perform the operation. So based on this operation, operators are of three types. When we need only one operand, this is called unary operator. Unary. When we need two, this is binary operator. When we need three, this is ternary. Ternary operator. Okay. So remember, let us revise one again. To perform any operation, we need operand. Operands are nothing but symbols. When we are performing any operation, we need to know very clearly the operator type, then the operand type which we need for this operator, and the result which we are going to produce, that result type is also important. You need to know, you must know that before only. Next, based on the number of operand required for an operator, operators are of three types. If you need only one operand for the operator, then it is called unary operator. If you need two operand to perform the operation for the operator, then that operator is binary operator. If you need three operand to perform the operation, then that operator is ternary operator. Okay. This is depending on the number of operand required for an operation. For an operation, depending on the number of operand required, operators are of three types. Three types. So we can say here three types based on the number of operand required. First one, unary operator, binary operator, and ternary operator. Okay, these three types based on the number of operand required. Based on operand required, this is of three types. Unary, only one operand is required. Binary, two operand. And ternary, three operand. Okay, in more details we'll see little later. Next, depending on the type of operation, for example, we can have something like this. Say we are doing 10 plus 20 is 30. This is an arithmetic operation. Or we can say a greater than 10 greater than 20. This is not arithmetic operation. This is an relational operator. Okay, relational operator. This will give either true or false. So here result type is true or false. It can be either true or Boolean type, but operand type both is integers. Operand type and result type we need to understand. This is Boolean. And for these, all these are of integer type. Operand, both the operand type and result type is of integer type. So this is arithmetic operation and this is a relational operator. Or you can say int a is equal to 20. Now this is an operator. This equal symbol is an operator. This is assignment operator. Okay, this is assignment operator. So depending on the type of operation, this is arithmetic operation, arithmetic operator, relational operator, assignment operator. Then you have logical operator or not, and like this. So depending on these type of operation you are performing, operands are again divided into multiple types. Multiple types of operands can be there. And these are types of operations. Based on types of operations you are performing, operands can be of arithmetic operators, or you can have binary operators. Sorry, but not binary. Binary you have seen two operands are required. String concatenation operator. Third one, assignment operator. Fourth, increment and decrement. Fifth, relational. Sixth can be logical. New operator, new. Instance of conditional, and 10 is bitwise operator. types. Okay, so this is depending on the type of operations you're performing. Operators can be of 10 types. Based on number of operands required, operators can be of 3 types. So first one is arithmetic operators. In arithmetic operators, again, we have 2: unary and binary. Unary and binary. So in these unary operators, arithmetic unary operators, you have plus and minus. Arithmetic binary operators, plus, minus, multiplication, division, and mod, right? So these are arithmetic unary operators. Means arithmetic operators are plus, minus, multiplication, division, and mod. Out of that, plus and minus can be used in both either unary or binary, in both the way. Okay. Let us take some example, then it will be more clear. I'll save that as test20.java. And this is test20. Say byte or go with int a is equal to 10, int b is equal to 20, and int c is equal to a plus b. So I am using arithmetic binary operator. Binary means 2 operand is required, and result is c. Okay. Now if you print c, you should get 30. This is we don't need. Save it, test20, and execute. This is 30. Fine. Arithmetic binary operator plus we have used first. If you use unary, or you can say int d is equal to a minus b. These operations, plus, minus, multiplication, division, you try to do. Okay, I'm not going to show all these things. Like this you can do. That is okay. It will print a value. A minus b is minus 10. It will print in d if you print. But I'm not going with that now. What I'll do is d is equal to minus of a. Minus of a. This is arithmetic operator, but we are using that as a unary. What it will do? The value of a is 10, and now this is arithmetic unary operator. So this value will be stored here as minus 10. Compile this. This is D. Save and execute. Test20, and it is minus 10. So this is arithmetic unary operator. But this is arithmetic binary. We are using as binary operator. This is as unary operator. But if we do something like this, say int x is equal to minus 20 and int y is equal to plus of x. This is okay, but this doesn't make any difference, right? This remains is still minus 20 only. So if you print y, it should be minus 20 only. It doesn't make any difference. Compile and execute. Is minus 20. So this is plus and minus arithmetic unary operator both you are using, but this is arithmetic binary operator you are using. Now, what is the important thing is result type. Result type is very, very important. Let us take another example. Test 21. And save this as 21. I'll consider here byte and byte b is equal to 20. Now byte c is equal to a plus b. This should be okay, right? Now c should be printed as 30. But if you compile this test 21, it is an error, okay? Incompatible types, possibly lose of conversion of bytes. What is the meaning of this? At this point, operation fail at this point. What it is doing is, when you are saying byte A is 10, it means it will have bits, 8 bits of data, 8 bits, and this is sign bit. Sign bit. And the value is 10, so this should be 1000 something like this, right? It should be like this. It will not be 10, right? It will be 2, 8. So it should be 1010. This should be the format of 10. So it should be 0, 1, 0, 1, and remaining fills with 0. Remaining fills with 0. This is 0 because it is sign bit. Similarly, B, 8 bits of memory, again it is byte. 8 sign bit, another bit, then it goes like this. And again it forms something like this. Say 0, 1, 0, 1, 0, something like this it goes, and 0. This is sign bit 0. Now when you are saying A plus B, it means this, and storing into again C of 8 byte. 8 byte of C. Something like this. So when you are adding this value, 8 bits and 8 bits is not possible to store in 8 bits again. Chance is there that this can be 1, this can be 1, all is 1, all is 1, this all 1, 1, 1, complete 1. Then when you add these two, the value becomes out of range of byte. So there is a chance you may lose something. So it is saying some bits you can lose. So it is saying this is not okay. So what you have to do is, you have to remember the result type also. This type is not valid. Type is not valid. Okay, we'll come to that type, but in this scenario, currently how it is, if you see this is 10 and this is 20, so the result is 30, and 30 is easily possible to store in next 8 bit of data, right? In this C, 30 is easily storable. Then why it is not storing? Because it is not considering the value 30 now, it is considering A plus B, and currently A is 10, currently B is 20. Chance is there that A can go up to 127, B can go up to 127. If the value is at the max, then what is the result? The result, whichever is coming, cannot be stored into C. It is a variable. A and B is variable. The value can change any number of times. And you are saying whatever value is there in A in B, add these two value and store into C. This is what you are telling. Now it is 10 and 20. It is fine. Compiler is not understanding the value 10 and 20. Compiler is understanding A and B. A and B can be any value. So it is giving this error. But what if I say A is a final, no chance to change? A is final, B is final, no chance to change. Then in that case, we have seen this will work fine because there is no chance to change. Compiler understand, okay, 10 and 20 is 30 and 30 is always easy to store into C. It will not give any error. Okay. But as long as these are variables, we'll always get this error. Then what you have to do when you get the error, what you have to do? When you get the error, you should consider this as integer type. Why integer type? Whatever value is there in A and B, always possible to store in int because int size is 4. So 1 byte and 1 byte, 2 byte. In 4 byte, you can easily store. So if two options we have. Either we have to declare A and B as final and initialize, or take the C as integer type. Two options. Any two is fine. Now let us try both the option. First, I will declare both A and B as final. And this is also final. Now you save it and compile and execute. It is 30, no issue, it is fine. Or this, and this I'll consider as int. Now you compile and execute. This is also fine. Any one is fine. So what you have to do is, you have to remember. So always there is no, you should not declare a variable as a constant final, because when it is a variable, it means it is not constant. It is going to change. And if you know these two are final, then instead of writing the variable here, you can directly write here 30 because it will change. It will not change. So directly you can write here 30. You know that always C will be 30. So normally when you declare a variable, that should not be final. When it should be final, we will come little later. Currently, it should not be final. So you have to understand the result type. So you remember when you are performing arithmetic binary operation, and the operands are, we have seen, plus, minus, multiplication, division, and mod. Okay, these 5 are arithmetic operator and can be used as a binary operator. So you need to remember the data type. Data type is when binary operator, okay, it is binary. I'll say operand 1 plus or operator or minus operator, plus operator or minus operator, operand 1 plus operand 2. Then what is the result? So if operand 1 and operand 2, any of these or both of these is lower than int, any of these or both of these is lower than integer type, then result type will be always int. Okay, any one of the operand 1 or operand 2 is lower than integer type, then the result type is always int. Lower than in the sense if it is byte or sort or lower than or equal to. Okay, any one of this is int or lower than int, then result type will be always int. Clear, right? in case of unary binary arithmetic operators, any one of the operand or both of the operand is int or lower than int, then result type will be always integer type. Result type is always integer type. But any one of the operand is higher type or both of the operand is higher than int, this is not simple, right? This is lower than int, lower than or equal to int, higher than int, then always the result type is higher type. For example, operand 1 is long type and operand 2 is byte type. Which is higher? Long type. Result will be long. Operand 1 is short and operand 2 is long. Result will be long. Operand 1 is int, operand 2 is long. Result will be long. Operand 1 is long, 2 is long. Result is long. So any one of the operand or both of the operand is int or lower than int. Result is always int. Any one of the operand or both of the operand is higher than int, then the result type will be higher type. Higher type in the sense, you can have like this, int plus float, then result will be float. Means 10 plus 10.5. Result will be 20.5 and this is float type. This is higher type, so result type is higher type. 10 plus double, result type will be double type. Okay. So binary, even arithmetic binary operators, any one of the operand or both of the operand is int or lower than int, result is int. Any one of the operand or both the operand is higher than int, result type will be higher type. You remember these points, then this is done. Now, okay, take another example. So this is int fine, and byte means both is lower type, so result type will be int type. Take another example. Sort s is equal to 33 and sort t is equal to 22. Then sort u is equal to s plus t. This is not okay. This is not good. Compile it. Same error. Possibly lossy of conversion. So what you have to do? Both the operand is lower than int. So the result type should be int type. Now it is okay. If it is int type, now it is fine. Or int I is equal to 10 and int, or you take sort j is equal to 99. And if I take sort k is equal to I plus j. This is not okay because int or lower than int, result should be int. So this result should be int type. If you compile it, this is not okay. Compile, not okay. I and j is not valid. So this should be of int. Now, int m is equal to 90, n is equal to 80. Int o is equal to m plus n. Compile, this is okay because int or in lower than int, result should be int. Compile, this is okay, no problem, and you can execute. Okay, so this is, or if you do it like this, take another example. .java. different operation you do. Byte is equal to A and B. Compile test 22. This is not okay. Same error. This is not okay. This should be of type int. Any operation you do, okay, any operator, arithmetic, even binary operator, any operation you do, this should be int or higher than int. Otherwise, not okay. Now this is fine. What if I do like this? Say int, we take here only, int x is equal to 99, float f is equal to 10.02, something like this. And if I say result y is equal to x plus f, it should not be okay because float is the higher type. So the result type should be float. This is not okay. This is from float to int, not okay. This should be float type. Okay, another problem is there. Now if you compile, this should be okay, right? But it is not okay. The reason is, compile again. It is not okay because this value default type is double type. And when you're storing into float, you must explicitly say here 1f. Now it is okay. Now higher type is float type. So the result should be of float type. Test 22. This is okay now. Okay. This f you have to add. Otherwise it will be considered as default type. So not okay. Another example. Test 23. Int a is equal to 10. Int b is equal to 20. And int c is equal to say 4. Now int d, result I want to see. Result is d I am storing, but the operation is a plus b into c. Now how the operation will be and what will be the output? I'm printing d. The operation should be normally b into c first, right? B into, because this is having highest precedency. So c, b into c, which is 80, and then 10, the output should be 90. Compile test 23. Test 23. Println. Save. Test 23. Okay. Test 23. It is 90. Fine. Now, if I want another operation, something like this, E is equal to this one. If I want to perform this operation first, A plus B, then what would be? A plus B is 30. 30 into 4. 120, right? Compile it. Sorry, it should print E. Save and execute. Test 23. 120. So you need to understand the precedency. You can do like this if you want to perform this operation first. Okay. So this is arithmetic operators. Unary and binary, very simple. You can try those on your own. Any doubt, you can ask in the class. We'll go to the next. Next one is, so these two you have seen. String concatenation operator, and the operator is plus. Okay, the operator is plus. How you will do is, test 24. Test 24, and suppose the operation is, say, string str1 is equal to hello, and string str2 is equal to everyone. Something like this. And str3 is equal to str1 plus str2. Now print str3. str3. Save it, test 24, and compile. Test 24. And one extra came. And compile. Test 24. So hello everyone. It is concatenating, adding. Okay, both a string 1 and a string 2 adding together and storing into str3. This is a string concatenation operator. But the same operator we have used for arithmetic operation, right? So this is we have used, right? Now if I say something like this, int x is equal to 99 and str1 plus x. No. Then what will be the result? The result will be string again. Okay, string str4 is equal to. So now what it is going to do? str1 is hello, and x is 99. So x value will be concatenated with str1. That means it will be hello 99. Okay, hello 99. Now print str4. Compile and execute. Hello 99. So now in this case it is performing the string concatenation, not arithmetic addition. Okay, this is not arithmetic addition. This is not arithmetic addition. These are string concatenation, and it is result is string type. So you understood from here, for plus operator, if any one of the operand or both of the operand is string type, then it will not perform arithmetic addition. It will perform a string concatenation, whatever value it is. For any value, plus symbol you can use to concatenate with other string object. Okay, to concatenate with other string. To concatenate with other string. Next, suppose if I have something like this, int a is equal to 99, int b is equal to 88, and string s is equal to, say, Java, something like this. Now if I print s plus a plus b, and because this is string type, so result will be string only, it is understood. I'm saying it is result is. Okay, this is result. If you print that, now see the output, how it works. Result. Compile this and execute. See how it is, Java 99 and 88. What it is doing, it means it is this order. S, how it works is, it operation is in this order, okay, from left to right. So S plus A, result becomes of string type first, okay. So it is Java 99, a string value, with this result B. So it becomes Java 99 and 88. It is in this order. But if we go in this order, then 88 and 99 has to add first. It will perform in this way. And then Java will be added with this. But it is not like this. It is left to right, not right to left. Okay, remember this. So if we want to modify now, say if I do something like this, another one, result 1, result 1. Now it will perform AB first, then it will concatenate with S. Compile it and execute. Now see how it is working. Okay, so this is string concatenation, how it performs. Next is, you can say another thing like this. Suppose say int I is equal to 101 and you can say value of I is plus I. Now what is the meaning? This is a string. With that you are concatenating I 101. So it will print value of I is 101. It will perform the concatenation first, then it will print that result. Okay, compile it and execute. This is value of I. Okay, so this is string concatenation. Or another operation, you can say something like this. Say I have a value int j is equal to this one. This is integer value. I need to convert this value into string format. I need somewhere this in string format. What you can do is, we know any string literal, any string value you add with any other type of variable, it converts to string type. Result is always string type. So what I'll do is string SS is equal to J plus one empty string I'll add. I'm adding one empty string with J. Now, whatever result will become of type string. Any data you concatenate with a string, it becomes a string. So 9999 is integer value. I'm concatenating with an empty string, and we have seen empty string is a valid string literal. Any value, any number of value. It can be 0 even for a string literal. So this is a valid string literal. Now, if I store this value into a string type, it is fine. It will convert into string type. Save it and compile. I'm not printing because it will print the same value only. Now it is compiling fine, means this is okay. You concatenate any value you want to convert to a string type, concatenate with an empty string. It is very, very important. Next is, suppose if I take another example. Say we have seen this one, value of I, how we have did, something like this. Instead of this statement, if I write something like this, value of I minus 1. Now, what is the meaning? What is the value of I? That should be 1 should be deducted from that, means 101 should become 100, and that 100 has to concatenate with value of I. Compile it. This is not okay. This is not okay. It is bad operand types. Bad operand types in the sense, for the operator minus, we need integral data type. Int, short, byte, long, something like that, float, double. But in this, we are getting the operand of type string, this value, how it is. So how the operation will perform? Operation will be left to right. Left to right. It goes in this way, left to right. So how it will operate? First, value of I is concatenated with 101. So this is a total string becomes, and on that minus 1. For minus operator, operand type should be integral type. It cannot be string type. So it is saying for minus operand, this is the integral value fine, but this operand is not valid. This is the error message. You see now, bad operand type for binary operator minus. This is not valid. String operand is not valid for arithmetic operation minus. So now I want to perform this operation. What you will do? You put it in this way. You have to increase the precedency. Now this operation will perform first. It will be 100, and 100 will be concatenated with value of I is. Compile it and execute. Compiled and execute. Test 24. Now this is 100. Okay. So this is another very good example. Like, so this is string concatenation operator, and two operator we have seen, arithmetic operators and string concatenation operator. Any doubt in these two? We have seen these two. No doubt, right? Okay. So if no doubt, we will stop here today. We'll continue next tomorrow from assignment operator. Thanks everyone. Bye-bye.